one of you except Willie soon can keep the phone, just in case an emergency call from Al Gore calling for some discussion. All right. Okay. For all you know, first of all, welcome all the newcomers and also the past campers. And I want to remind ourselves what we are doing here at Camp Constitution, which I'm very proud to be a part of now. I'm a staff. Thank you. We are here to honor the past, and we're here to teach the present, even though I say I'm not mature enough to teach. But I hope you can learn something from my talk. And then we are trying to prepare for the future. I have a switch in my schedule. I'm going to have a second talk. I'm doing the second talk first, and then the second talk last. Whichever the order is. I probably got it wrong already. It's simply because, as I say, I don't want to talk about the sun when the sun is already set at 7:45 on Wednesday. So I would talk about the climate prediction, the field climate prediction for 50 years on Wednesday. So we will talk about sunspot cycle. First of all, I do have to claim that I came here as a private citizen. My passion is do what I can to try to tell you as much as I know about certain subject. I'm a scientist by training, and my passion is really science and family and God. And what I want to tell you today is a story that I waited 31 years to say. Because I've been sitting around learning about sunspot for a very, very long time. Not because I'm a very slow learner. As most of you know, I'm the second fastest gun in the West. Not the first. The first always got shot. All right. I have affiliation. I work at the Harvard Smithsonian Center for Astrophysics. They don't like me to talk about things like this, so I have to disclaim that I'm not talking on their behalf as a private citizen. This year, I have a new affiliation, so I diversify my science portfolio. I have a new affiliation with the Institute of Earth Physics and Space Physics in Hungary, of all places. This place, they will be proud of me speaking, so let's start. I want to give credit to my friend. This guy is from the best university in Mexico. His name is Victor Manuel Velasco Herrera. So this is a joint work that we do. In fact, we've been sitting around this kind of topic, kicking around for a long time. Like I say, this year everything fall into places, so we already have 2 scientific papers on this. And I waited 31 years to write these 2 papers. First, the sun. Obviously, it's a big fiery object, yes? Yes. If you, for the scale, you all can find where the Earth is, right? It's about 110 times smaller. Not only that, it's not about the size, it's about the energetics. If you look at the energetics, it's very clear. The sun is very powerful. Never mind how much power it can give, 10 to the power of 26 watt. The Earth itself barely have any energy. In fact, most of the power comes from the sun. There's only tiny amount of radioactivity in there. And the world's most powerful laser we can make is somewhere coming close to the power that the Earth could emit itself. So it's quite interesting in that aspect. But that is done by Chinese scientists, by the way. The first thing I want to remind you is that because you all know, everybody heard about United Nations Intergovernmental Panel on Climate Change, yes? IPCC, right? You know, you guys know what IPCC say, right? Carbon dioxide is causing global warming. This stuff from your breath, actually. It's not joking, it's serious. But they say this one doesn't count. It's the one from the fossil fuel that is count. That's what they say. But I'm telling you, the molecule CO2 doesn't know the difference between this guy from there or from gas, from the cow fat or whatsoever, right? It's not true. I want to remind ourselves that the most important aspect of the sun and the Earth is basically this orbital motion around the sun every year that we know. The best way to capture is to see this thing. At a particular point, you see how the sun changes in the position in the sky, right? This is the season. In fact, this power the whole energy system. There's no amount of CO2 you can put in that could change this fact, okay? This is why they say that CO2 will not be powerful enough that it could change the climate system, but the sun cannot. That's what they say. You all believe in that or not? Okay, here's a way to see this. I want to give an analogy. Science, if you can give an analogy that is accurate, I think is very, very good. Here's why I want to show you that what they say that carbon dioxide can cause global warming, but the sun cannot cause global warming is total baloney. Well, it's a lie, okay? Think about the climate system is Refrigerator Perry. It's a football player from Chicago Bears. You all know from the 80s. That's the only time I watched football. I have time back then. And then the sun is King Kong. And then CO2 is Al Gore. As I told you, I keep the phone here just in case he call me. What they say that CO2 is so powerful and the sun is weak. King Kong is weak because he drink water. So he drinks some water, so he gained very little weight. Al Gore, on the other hand, eat a lot of hamburgers, so he gained a lot of weight. So therefore, he can take Refrigerator Perry and shake him up and down, right? Controlling the climate system. Whereas CO2, sun cannot do it. That is a clear baloney, okay? And this is a bit of an equivalent to say that, you know, there's an asteroid. Look how close the visitor center is near the crater. You all know that kind of problem, right? It's causality and that sort of problem in science. And these people are very good at following the narrative. This is scientism, this is not science. Scientism, how do we define it? It's just doing all kinds of shaking and all kinds of science. I'm talking science left and right. But there's no science being done. It's all that kind of move. Hand waving and joking around. So, believe me, for IPCC, this phrase applies. Blind belief in authority is the greatest enemy of truth. I also want to take a chance so that my wife won't be mad that she's not here. It's my wife painting for her college year. So, are we going to be in the age of enlightenment or age of anti-science, right? It's a bit like anti-Christ. These people are really, really bad people. They are not good people. So, studying the sun. It's been studying for a very long time. Here is just to give you an example that sometimes sunspots appear, but you can actually see with your naked eye. But of course, never ever stare into the sun directly, right? It's going to hurt your eye. But there is sunspot there. It's been studied for a very long time. You know the Chinese has been observing the sunspot since about 837 AD or CE. All right, the Japanese also have some observation. And then the Song dynasty go back even further, before Christ. Okay, so it's a long time, and I happened to write a book that talk about story like that long ago. Not to sell book, but it has a passion of love for science. And then the Chinese emperor, this is from the Ming dynasty. It's in fact, this guy is very unfortunate. He was only emperor for a very short time. But he also painted globe of the sun with his paintbrush is a bit, so making the sunspot look really too big. And then from the Western culture, John of Worcester already observed sunspot, described sunspot. And then you can see the east and west. It's universal phenomenon. That's why science is all about eternal truth, right? If you see that in the Western culture, can you find it in the Korean? For example, here, the Korean culture recorded some aurora event. Aurora is one of those colorful light that dancing near the polar region of the earth, right? North and south, right? Where the energetic electrons and protons coming from the sun is interacting with our earth magnetosphere. All right, that's a sunset recent eclipse. So, today I want to report to you, this is why it took me about 31 years, right? We have a possibility. I cannot even imagine that I have this possibility to discover the first sunspot drawing in America. This is all from all kicking around, checking around, and asking the question, who is America first make that kind of drawing, right? In fact, there were some earlier people, but it turns out that Humphrey Marshall is the right person. He has corresponded with our great founders, which is Benjamin Franklin. So he lived during that era, 1722 to 1801. I'm showing this photo mainly not to point to his portrait, because no one has his portrait. This is actually a model. But I want to point to all this instrument that was brought to him by Benjamin Franklin in England. So these are the real instrument that is still around actually in Pennsylvania. And it turns out that this guy, Humphrey Marshall, is a botanist, so he only studied the sun during winter. So it's okay. Free time, summer, he'll be too busy doing all this. A lot of his flowers are very beautiful. It's in many gardens in European kings and queens even, right? And so this guy is indeed legit guy. So let's not read him, but he did wrote a letter to Benjamin Franklin talking about his observation. He observed the sun for more than actually not 12 months, 2 years, and he made about 300 sunspot drawing. And this drawing actually was reported. Okay, Ben, that's a portrait of Ben Franklin. And he actually was published in one of the prestigious journal in Royal Society of England. So Ben Franklin gave these things, and then they published this stuff, and then in that, it described that he has about some drawing of sunspot. In fact, by now, people thought that the sunspot disappeared, the drawing disappeared. It turns out that I met this guy. First of all, there are several people that describe sunspot in America. Braddock in Boston, 1694. Robbie in Boston, 1722. Winthrop in Cambridge, around Cambridge, Massachusetts, 1739. But no one ever found the picture. But it looks to me that this guy, he's a Quaker, same like Humphrey Marshall. He actually think that he has seen this production of the sunspot drawing now. So he says he's going to try to locate for me this picture. When we have it, this is truly the first, because it's already been reported lost about a few years ago by one of my colleagues from Spain. But obviously he was not looking. And then from Maine, we happen to have Reverend Jonathan Fisher. This is slightly later now, right? 1816, so it's much later, but the earlier one is really responsible by Humphrey Marshall. Just an example of how a lot of the information are very useful. Later, I'll put it in context, because you want to know where the sunspots are, right? With respect to the rotation of the axis and in respect to the equator and where the sunspot is located. So, I'm going to start telling you about this sunspot activity. By the way, it's been observed many, many thousand years ago, like we say. But we want to start the era of using telescope. Okay? That will be starting around Galileo Galilei time, right? It's about 1600. Okay, he is a very, very brilliant man in some sense. So he was one of those early guys who not only understand what science is about. Science is about observation, measurement, testing of ideas and all that. He also tried to know that this science is about searching for universal truth. So look at what he did. He actually put the telescope out there in Rome, let people look through it. If I see that the moon has crater and all that, you got to look through it yourself. You can see it. Right? This is about sketches, his famous sketches of the moon, craters and all the places. And then, of course, he also turned the telescope to the sun, so where he observed the sunspot. And he realized, he made this realization, because in the beginning, people thought that, those dark spots, they're just something in your eye or some dust and all that stuff. He actually made it realize that this thing is the actual thing that carry with the sun, because he had patience enough to watch it for months to see that this thing is carried about by the sun's rotation axis. In fact, I have an image to show you that, a collection of his observation in 1613. This is based on many days of observation, obviously. Right? And he even realized he already got it right at that time, because he realized that, the sun, it's relative to the orbital plane, is about off by 7 degrees, roughly correct already at that time. This is what good observation do to you. And it gives so much enormous information. The sun, we know, is a fireball. Its energy is powered by nuclear fusion. It's actually take two protons, you merge them together, you fuse them together under enormous pressure. And then the temperature come of it, right? So you form helium. So we've been converting hydrogen in helium in the sun's core, the inner 30%. Outer 30% is the region called radiative zone. Outside is the flow, the fluid flow. And then that's what we want to study now is, of course, all kinds of features about the sun, but today we're going to focus on things called sunspot, right? It's amazing, actually, when I was doing my PhD, I don't mind admitting, because you really do not know things. I didn't even know what a sunspot is. And that was in 1991 when I finished my PhD. That's how embarrassing you are. This is what education is all about. And I got a PhD in plasma physics. I'm not joking. But of course, I came to Harvard Smithsonian to do my postdoc. That's when I got, my passion was in sunspot. Now, of course, when I wake up at night, I was whispering, sunspot, sunspot. Did you hear it? Okay. Okay. All right. There are all kinds of features here. The main thing is that the sun is a magnetized body, which means it's magnetic field. By the way, the earth is also a magnetized body. But if you measure the strength of the magnetic field, it's only like something called 1 Gauss, named after Gauss, a very famous mathematician. But the sun one, near sunspot, is concentrated 5,000, 10,000, Gauss. So it's very, very strong, very strongly magnetized body. And you can see the close up to that. And the dark part is basically saying that it's slightly cooler than this region. And then this part called penumbra is actually because the magnetic field was not straight up. This is actually flow straight. This is inclined at the region. And all these are boiling porridge. actually. It's convection cell, by the way. And then you can look at another angle. And then what we can do today. So what we do now is actually put things in mathematical equation and we try to simulate. This is actually one of the computer-generated sunspot. So it's amazing. Think about how far we have gone, right? From Galileo looking at the sunspot. Now we can do that in a computer. Trying to study the three-dimensionality, all the physics, how does it work, the magnetic field with all the radiations and all that stuff. Even that, you can see Galileo very early on already realized that this sun is basically, sunspot can stay sometimes very short, very transient, sometimes big body break into multiple pieces and things like that, and going around and then things like that. So he really was making good observation. Even the old French astronomer royal by the name of Cassini was observing sunspot in 1676, as you can see this case. He actually said that this one has a hexagonal shape, right? Look at that, it has a hexagon. Actually, this is the value of good observation, which is true. This phenomenon can be verified today. You can see one of the shapes that look like hexagon, right? It just tells you more about nature, about how this sunspot was formed, of course, if you know more about it. And then these are just collection of, this is not one picture, this is actually from multiple pictures, showing you the traces of the sunspot over time, right? This one is taken even over, well, you can see, more than 4 months, right? About 4 months. To do the 100 days. And the discovery of a sunspot activity cycle was by this German guy named Samuel Heinrich Schwabe. He's actually a pharmacist. Again, a lot of these are all people and nobody was going out to study, I'm a sunspot guy. No. This guy is a pharmacist. During his free time, he watched the sun. So this is his observation. From about 1826, so about 17 years, he do this. Guess what he saw? This is the discovery. But he dedicated 70 years of his life to watch this thing. He counted the number of sunspots appearing every single day. Then every year he count how much together, average them, and then he find them. Look, it looks like it has a sunspot cycle. Every 10 years or so, it go up, high and low, right? And this is actually true. You can actually do this thing and then you plot the location. That's why the position of where this thing is in the sun surface is very important. This is the latitude, equator of the sun. 90 degrees south, 90 degrees north, right? 30 degrees. So it never formed anywhere here, but it formed about 45 degrees. And then it looked like a butterfly wings. And the reason why, and in fact, those guys, these two persons, by the name of Walter Maunder and Annie Maunder, these are the first two who proposed how to make the plot. In fact, I'm so profoundly indebted to these people that there's crater in the moon named after the Maunders, right? I wrote a book called Maunder Minimum to that name after them. And it's about an episode of the sunspot period where it's very, very important. Okay, I'll explain that in a minute. So, this is when the Maunder realized in about beginning of 20th century or end of 19th century, where they realized that there was a period from 1645 to 1715. Okay, this is a 17th century time period where all the sunspot appear to disappear. There's no sunspot. For 70 years you don't see it. That is really rare. You can actually not see sunspot for maybe like 1 year, during minimum, when there's no very small amount. But this one, for 70 years, people keep looking, but there's not there. So people say, oh, maybe that's not real. So this is the period I'm referring to. This is really one of the important things that we wanted to know. Why, right? We want to know why. Not only they do 11 years, sometimes it disappears. And what is important during this period, obviously, if you think about the climate, is that during this time, it's very famous in Europe, where you have the frost, fair age, little ice age, the time period called. But that's another aspect of the scientific research and our conduct. It's very controversial. People want to fight me all the time on that, but I'm actually among the experts on this topic. And this related, people say, oh, because of the Sun King, Louis XIV. Look at the time in which he reigned. Very, very small, very clear, close coincidence to the time of the Maunder Minimum, by the way. And the people that make this hall of glass in the Versailles Palace happen to make the telescope that we use to study at Mount Wilson Observatory to study this sun phenomenon. So it's very, very nice coincidence. And my colleague from France, Elizabeth Nemre, that actually used the phrase broken butterfly wing during Maunder Minimum. See, during regular time, you have regular butterfly wing. But during this time, you can see the northern hemisphere, there's no sunspot at all. The southern have a little bit, and you look, it's more confined. Before this one stretched to about 30 or 40, this one does nothing, very confined. So what do you think is this relevant? So in fact, this is very, very important for us to try to find out how does it happen and why does it happen, right? So this is the modern update. I want to tell you that this is ongoing study, that we keep learning and searching for information and all that. This is like just published about 2 months ago, right? So let me see. What's the relevant of a modern minimum? Another relevant is actually coffee. You all know, right? There's no coffee before this modern minimum period. The first coffee house in England is 1652. It's those Oxford students, right, who want to. So people say that it's an enlightenment, right? The coffee. I love coffee, so please pardon myself. And you know, a brew of coffee is very good. It keeps you studying. So now I want to talk about my work with some of my colleagues, Victor Velasco and Douglas Hoyt. And we apply this thing called machine learning, which is a new technique. By the way, in science, it's not only that you try to find out the thing, you have to create the tools. You know, the tools, like you need a hammer to hit the nail in, right? Yeah. Right? So you have to create a tool. This is one of the new tools that Victor Velasco is an expert of. That's why we sit around the bench for so long. This thing is only started maybe 21st century kind of ideas. So with the machine learning, you see how smart this machine is? You can tell the machine, can you stare at this Vincent van Gogh drawing, right? Let me give them 100 of those paintings. Let the machine synthesize, see the pattern, and see the way it paint. This one is completely generated by the same machine algorithm that we're using to do sunspot forecasting later. So it make a plot like this, a picture like this. We don't give any guidance. We just say, make a plot that copy this pattern, and they do it. So it's very, very real. This thing is real. By the way, there are always good and bad, right? Please. Yeah. You know, in terms of this computer versus human, that kind of stuff, it's always good and bad involved. But there are certain aspects of these things is very useful. This is why I keep learning about the tools. Never be afraid of the science. Never reject science. Science is the ultimate, you know, tools to seek truth beside God, right? So what's new in this work that we do? We use this method. We try to reconstruct the sunspot record. Okay, we successfully show all of that, and then what we do is that we found out that during certain time, the sunspot is missing. That's actually important because we are correcting past error. Like in the past, during that time, no one was watching, less watch, and then we found that there could be more sunspot around. So that is our prediction, by the way. And then we forecast the thing towards the future. You know what we found that is very important, that will be controversial? We find that the sunspot now is very, very weak. And it's going to stay so for about even up to another 30 years until 2050. So I'm forecasting into the future. This is why it takes me so long to have certain confidence that what we do here is not baloney. It's not something that's going to fail tomorrow, okay? It will not be failed until we wait another 20 years or so to see this. So this is how good our forecast is, right? This is the old observation, which is the black line. And then you can see the blue and red lines are our hindcast. So this is for the period that we already have data. But we check how good is our calculation, our prediction using the machine algorithm. It's quite good. And this is why we believe, see, you see the red line there, the future going to look like this. This is the period that I'm referring to. Okay, and then it's going to get active again. And then we found out that during this period, we actually ought to have more sunspot. And this is actually true because if you look at the statistics of how many days you count, for example, my good friend Douglas Hoyt, which I will show you his picture, is that we found out that during this period, look, there's not much observation. So the chances of us saying that there will be more sunspot than actually was observed, recorded, is quite viable. This is what we propose in our paper. So forget about the code, but the code is trying to tell you that these are the period in which you have not many good sunspot observation. So the idea of missing sunspot is very real. Okay? So we show the prediction. So this is the period that we think is going to be very, very important climatically. So this is actually a good test of this global warming hypothesis versus the sun, isn't it? Let me speed up. This is another one that I'm going to name after, another chance to show my daughter's work. So shamelessly. So now part two. Part two, now we're going to study another thing. Sunspot, as you know, come in so many phases. This is one of the things that we're studying. When they come in groups, okay? This is big. You can imagine the Earth is no more than that little dot there, right? So we're studying the sunspot group record. It's very, very important why we do that, because this is a very accurate way of counting sunspot, because there's a real problem about how do you define, how do you count sunspot, that kind of thing. Why do you count all the tiny spot? Tiny spot is actually less relevant in some sense. But this is the example of sunspot structure. You can see how rich it is, but this is one of the examples of those giant sunspot groups that come together. So my colleagues, Douglas Hoyt, the man that under Hoyt and Sharton there, he reconstructed this result, okay? And we actually found that there are some problem even in the sunspot record keeping. This was a previous very big sunspot guy by the name of Rudolf Wolf from Switzerland. He actually committed some error. So I was telling Catherine why we waited 31 years. We not only have to correct all this postmodern nonsense, we also have to correct some past mistakes which happened in the 19th century. So this is a very serious work that we put together, this whole thing showing why and explain why, fully documented, everything is transparent. Indeed, you show that. So we show how good our result is compared to the previous version. And then we finally show so many of the features. This is actually all the information you fed into the computer to try to tell you how the sunspot activity really works. So the main thing I want to say is that we really think that if we do 3 more cycles, it's true that it's below, then I'm going to propose to name this Hoyt minimum, which is my own colleagues. This is Douglas Hoyt. Is one of the very, very good guy. But now everybody is calling him to be a fake guy, cheating, working for fossil fuel company, the same old thing. By the way, everybody think that I'm working for fossil fuel company. Obviously, it's not true. All right. So now, this is for the future. We want to compare the next sunspot cycle. You can see, right? It's going to be 3 or 4 more years from now. But this is from what you call the government, the NOAA administration, the Department of Commerce. They actually have a group activity. This day, right, everything is like this. It's about, if I predict this, everybody trying to do exactly the same thing, so they all get very close to each other, so we all agree with each other. It's a consensus, right? It's that nonsense about science. Science is never about consensus. It's about what is right, what is wrong. That's it. What is true, what is not true. It's a very simple proposition. And I spent all my life not to go against them, just simply that this is not even a good question. This is what I mean by scientism. You just keep waving your hand and there's no science here. They're talking nonsense. I don't even know what they're talking about. This is why I tell you the truth. My confession is that as of 2004, I've been studying this for a long time. As of 2004, I no longer want to take a single money from the taxpayer funding. Namely, they all claim government funding. No, government is not giving me funding. It's from the taxpayer, right? So 2004, I stopped. I used to get money from NASA, Air Force, and all that. Now I just say, whoever want to donate, give me money. I'll do my research. That's it. But don't tell me what to do. Don't tell me what to write. That's the only thing I reject. I want to remain as free as I can. It's a hard road. It's very, very hard road. I don't recommend to everyone, but I can tell you, the beauty of this is that I'm very happy. I have 2 kids here. I have another daughter down in the junior camp. My wife is happy, I'm happy, my whole family is happy. What else do you want? Nothing more. And then if I can connect with some of you, that's why no matter what, I'm not worried. I can work in McDonald's, I can clean toilet, I can do anything. But if I'm good in science, I do some science. So I'm good in science, now I do some science. I've been doing that for my whole life actually. So I'm not worried about that. I want to compare their prediction with ours. So now the battle is this. There's another very famous person, okay? Let's not name, but he's very famous. He predicted the next sunspot high will be this much. 250, the number. We say it's about 90. So let's have a battle. Later we'll see, because we wait all we need to do is wait for 3-4 years. I'm not worried. If I'm wrong, I say I'm wrong. But this guy is already defending himself. When people start showing the recent data with his stuff, he say, I didn't say this. And then you look at his paper, this is exactly what he said. This is the kind of people, I don't understand this kind of people. They want the prestige. They want, this guy have permanent position, okay? They were just being paid to sit in a good office, and then they are a little bit smarter than average, obviously, right? But then they are abusing the power, in my humble opinion, okay? If you're wrong, you just say you're wrong, but he's already complaining, I didn't say this. He say that in all this Twitter space, you just show him, this is what you say actually. You just say that in your paper. Maybe you want to take it back, it's okay, take it back. You can do it now. I'm okay with that. But they just say, I didn't say that. No, you say that. Because it's beginning to look not so good for him. I don't care actually. mean, who knows? Maybe the sun all of a sudden will go up very high for him. Good for him. I really don't care. So that is our forecast. So we shall wait. Maybe 3 more years, you come back here, I'll talk again. Okay? I'll report you the whole truth. The final part is to say, why is it so important to predict this sunspot activity, right? Prediction is God's will, really. It's a very dangerous territory. This is why I really waited a very long time. I couldn't emphasize. Remember, 31 years is a very long time, you know. I had to get married. I had to have the kids to grow up. And he's almost went to college now. I waited because I couldn't be sure. I keep checking. This is a duty of a scientist, by the way. And people just neglect it. People just trying to say, oh, I have 100 papers. I have 1,000 papers. No. I have 1 paper. And 1 paper that is right is worth everything else. Nothing matters, actually. Why are they keep telling me all this nonsense? I have so many papers and this and that. How many people like my paper? How many people cited my paper? It's all very bad. This day, we don't have what you call peer review system. We have a power review system. This is how corrupted things are, which I'll get into more details when I talk about the failed sunspot prediction, the failed climate prediction. For 50 years, they're still spinning this thing. They're spinning this today. They're talking about the Germany flood and all that, but they forgot that 1717, during Christmas, 14,000 people died in Germany because of flooding. 1717, okay? There's no fossil fuel effects and so on and so forth. These people are talking nonsense all day long. Now, I want to talk about why it's so important. This one I want to emphasize this guy by the name of Richard Carrington. Not because he makes beer, he's a beer brewer, but he actually was so dedicated that he observed the sun. Oh, he's slightly shorter, he's less patient than Heinrich Schwabe, but he observed the sun for about 8-9 years, right? Every single day, from 1853 to 1861. Okay? This is his brewery where he do the observation while he was doing all this stuff. And it's very important. In 1859, September 1st, he reported this note. He basically showing this, which is a group of sunspots. And guess what he found? He found that for a short few minutes, seconds, that this whole thing brightened up. It's called solar flare. This is the energetic event that send all this huge amount of plasma, the gas, right? Plasma that come and then interact with the Earth magnetic field and then causing all the reaction on the planet Earth. Right. One of them is very clear. It's already, by the way, first thing he do is that he reported that his friend, the other guy, independent from him, Hodgson, observed the same thing. In fact, it's very difficult. Imagine you watch the sun and you're looking for something that changed only for a few minutes later, look like nothing happened anymore. They were so enormously lucky to see this, by the way, right? So another guy sees it, so that's very good. Checking, independent verification. Any work that you do, it should be verified by somebody else. Or else it's not considered to be anywhere even close to being truthful, right? Yeah. So, in modern time, you actually can go to the ice core. You know, in Antarctica, you can drill the ice core, you can try to date the layer, and you can find that indeed, if you measure something called NO3, nitrogen and 3 oxygen, right? And you find this peak that happened, that shows that it happened in 1859. Okay, so we're talking now serious science. These things are real. Right, rather than somebody's imagination. And then New York Times actually reported this aurora phenomenon happened about a few days later, 5th of September. Okay, sorry, just to give a little bit more credit to New York Times. And then one of the consequences of this kind of solar flare event, this day they also call another name called coronal mass ejection. So huge amount of plasma, right? Billions and billions of tons of plasma coming out. And it can actually cause damages to your electric grid, right, system. One of the famous one happened in 1989, right? This is the one that happened in Salem, New Jersey. And one of the estimates is that it could lead to something like a few $1 trillion kind of damages if you're not prepared for it. This is why it's good to try to see if you can forecast these things. Most of the problem is caused by lack of preparation. All this big transformer is very hard to manufacture, but no one want to buy a spare to be ready. This is why you could shut down for weeks with no electricity. One of these things got damages, okay? But they are not preparing. They actually have commission after commission. I've been to so many of these meetings that I refuse to go. Goodbye. No, they don't. They're not serious. They just want to have more meeting, more vacation, this and that going on. I don't know what's wrong with all these people. They just like to do this kind of thing, and then they just simply don't do it. They already spent enough money by now. They should be fully prepared for any kind of damages. Yet nothing is done. Okay? I don't want to discourage you. Somebody, we got to keep trying. For God's sake, we have to keep trying. You cannot behave like that. These people are so bad that I really, by the way, I have no respect for these people. They're just very bad. And then one of the things is about telegraph. The telegraph, this was recorded in real time. That it interrupted the transmission of telegraph. And then another very cute one is about why you think it's so important. Even the whales, God's creature, is being affected by this kind of solar flare event. And guess what they happen? Their navigation system, they know how to move north and south and all these other places, depends on the magnetic field of the earth that is interrupted by the sun's solar flare. This is where they're beaching. They landed on the beach, just die. No water to swim. More example of this. But in the past, we already knew about this. This is definitely not a modern phenomenon, right? 1577. This is an old painting from Holland, I think. Another one that I like old stuff, just to say that nothing we haven't seen before. We have seen it all, right? So another one, 1602, from there. And then this is why it's so important, and that's why we invest so much money in science in that sense. I hope this project is real. By the way, this one, I no longer want to participate in a lot of this project. Not that they will invite me to, but they treat me as a pariah, but I really don't care. I know enough. But this is what happened. This is the European Space Agency. Now they're proposing another proposal to try to detect this warning system ahead of time. One of their innovative ideas for all the students is basically to learn about is this new mission called Lagrange, which will be launched about 2023, right? It's a bad timing to launch, by the way, but it's during a solar maximum. But the main idea is that in terms of gravitational field, there are things called the Lagrangian point from L1, L2, L3, L4, L5. Why are those important? They predicted by the French mathematician Lagrange, right? That these are actually stable region of the magnetic field, of the gravitational field, where if you place the thing there, it can actually follow the thing, so it doesn't have to wander around. So it's very stable. It's like a gravitational trap. It's a hole. This is a very important concept. But they're going to place this guy right here at L5, so that if the sun coming, you can see it ahead of time, so you get a little time of warning, at least 3-4 days of warning. That should be enough for us to do something about it. But of course, you got to keep putting satellite up there, okay? If you want to have a prepared system. So this is what the whole struggle of studying sunspot is all about, right? Okay, I'm good. I'm done. Thank you.